if the y, if given, if given the y dx, then the dx of the y dx equals the 2y dx squared. If given the y dx, then the dx of the y dx equals the 2y dx squared. We read it as the 2y dx squared, which is the second derivative. So I want to look at how can we obtain the second derivative. Example 1. Given that y equals x cubed plus 2x squared plus 4x plus 5. And I've said find part A, the y dx, part B, the 2y dx squared. Let's look at the solution. So we are given that y equals, we're in part A. Answer to is part A. Y equals x cubed plus 2x squared plus 4x plus 5. So can we look at d dx of y equals d dx of x cubed plus 2x squared plus 4x plus 5. So when you differentiate y, we said you get the y dx equals, when you differentiate this one, what do we get? We are getting 3x squared plus 4x plus 4. That's what we call the y dx. Now, we are going to go to part B. They are saying us to get the 2y dx squared. When they tell to get the 2y dx squared is the same as d dx of the y dx. So this is the same as d dx of what was our dy dx. Our dy dx is already 3x squared plus 4x plus 4. It's already 3x squared plus 4x plus 4. So can we differentiate this one? When we differentiate 3x squared, what do we get? We get 6x plus 4, which is the 2y x squared. That's how we get that one. Whatever fraction it is, even if it is involving product rule, even if it is involving quotient rule, we are supposed to do in the same way how I have given you that. So after finishing that example, we are going to go to example next. We're going to go to example 2. And from there, so look at examples involving parametric equations. Here, so look at them. They have not come here to play. So we're going to go to example 2. Example 2. If y equals root x, find the 2y dx squared. So what we're going to do is this. We are given y equals root x, which is the same as x power half. So can we look at d dx of y equals d dx of x power half. So when we differentiate y, what do we get? We get the y dx equals, bring this is a half, x power negative a half. So this is our dy dx. So if you want to get the 2y, dx squared, how do we do it? You're going to look at d dx of dy dx, which is already d dx. What is our dy dx? Is a half x power negative a half. So how do we handle this? We are going to have a half. We multiply with negative a half. We say x, deduct 1. So you're going to say negative a half minus 1. So the LCM is 2. 2 divided by that, 2 then now minus 2, which becomes negative 3 out of 2. So this one becomes negative 3 out of 2. So from the use of indices, you can bring it down. You get negative 1 over 4 x power 3 out of 2, which is the same as negative a quarter. Or you can just say it is the same as negative 1 all over 4 root of x cubed. That's what we call the d2y dx squared. That's how we are getting that. So if they tell you to differentiate in that manner, that's how I'm expecting you to do your stuff. So we're going to look at another one involving the product. After that, then you shall go to those ones involving parametric equations. And so another example, it goes if y equals x plus 1 power 2 into 2x minus 3 power 4, then they have said find the 2y dx squared. So find the second derivative. How do we handle such a kind of a number? What we do here is very, very simple. We start by saying let y equals x plus 1 squared, again 2x minus 3 power 4. We differentiate as usual. This is u, v. Our u equals x plus 1 squared. Du dx equals 2 into x plus 1 power 1, there is like that. What is our v? V equals 2x minus 3 power 4. We look at the v dx. What is it? 4 into 2x minus 3 power 3 times 2. What do you get? 8. 2x minus 3 power 3. Then we shall say using dy dx equals v du dx plus u dv dx. What is our v? Our v is already 2x minus 3 power 4 times what is du dx is already 2 into x plus 1 plus what is our u? X plus 1 squared. Our dv dx 8 into 2x minus 3 power 3. What do we get? What do we get? And when you're saying yes factorize, what is common? You can see 2 can go there, 2 is common. Again x plus 1. Again 2x minus 3 power 3 into what do we remain with? Into what do we remain with? We are remaining with 2x minus 3, because this one is there outside and that one is outside, plus this one we are remaining with 4 into x plus 1. So can we go ahead and open? What we have in the 2 into x plus 1 into 2x minus 3 power 3 into 2x minus 3 plus 4x plus 4. So, can we guide this becomes 2 into x plus 1 into 2x minus 3 power 3 into 6x plus 1. So what happens? What does it become? So I've got our dy dx equals 2 into x plus 1, again into 6x plus 1, again into 2x minus 3 power 3. Now, from there, we can first open the first two ones, so that we can create two brackets to continue getting the 2y. So what is it? 2 into x times that, we are getting 6x squared plus x plus 6x plus 1 into 2x minus 3 cubed. So what are we getting here? What are we getting? We're getting 2 into 6x squared plus 7x plus 1 into 2x minus 3 cubed. I can even put a 2 inside, or I can leave it out. I can put a 2 there. What happens? This becomes 12x squared plus 14x plus 2. Again into 2x minus 3 power 3. This is dy dx. Now if I want to get the 2y dx squared, well, now our interest is to get the 2y dx squared. It's all about saying the d dx of dy dx. Differentiating this one, this is my u, this is my v. So want to apply in it. What is our v? 2x minus 3 cubed times. We are applying in this formula, which we use this one. What is our du dx? When we divide that one, what do we get? 24x plus 14 plus, what is our u? Our u is 12x squared plus 14x plus 2. When we divide that one, we get a 3 into 2x minus 3 power 2 times 2. So can we go ahead? What are we getting here? We can factorize out what is common, what is common, what is common. What is common is only 2x minus 3 power 2. What do I remain with? I remain with 2x minus 3. Again into 24x plus 14 plus the other one is already out to have remained is only 6 into 12x squared plus 14x plus 2. So we are free now to go ahead and open the brackets. So we are free to go and open the brackets. This one becomes 2x minus 3 squared into, we open 2x times that, we get 48x squared, 2 times that plus 28x, 3 times 24, here we are getting a 2, we are getting 72x, minus, that is also a 2, and that is a 42, plus, we are now going to push in 12 times a 6, that one is also 2, then you're getting 72x squared, plus, we are now getting 14 times x, I can see on my calculator, 14 times a 6, what am I getting? I'm getting 84 plus 84x plus 12. Remember, we are moving together. So from there, so this one So we are now moving, we are going to collect like terms. That's why I want you to be very, very attentive and very serious with this. You shall look for only parameters. And there, so I've already finished our second derivative. So we move on. We're getting 2x minus 3 squared into, we are free to open the brackets and collecting like terms. We are getting 48x squared plus 72x squared plus 28. Let me be collecting like terms on my calculator. 28. Let's move 28 minus 72 plus 84. So we are getting 40x plus 40x. Negative 42 plus 12. We are getting minus 30. Minus 30. So we go ahead. 48 plus 72. What are we getting? 48 plus 72. We are getting 120x squared. So our d2y dx squared goes 2x minus 3 squared into 120x squared plus 40x minus 30. If you want to factorize out a 2, I have no problem. You can maybe factorize it out to get 2x minus 3 squared. So what is common is a 2. Is a 2. Is it a 2? You can say times a 2 into, here you remain with 60x squared plus 20x minus 50. Can a 5 go there? A 5, yes, a 5 can go there. 5, that means what is common is 10. So we got 2x minus 3 squared times 2 again times 5. 5 goes there how many times? 5 in 60 goes there how many times? 5 goes there how many times? 5 goes there how many times? We shall say it goes there 12 times. We shall say 12 x squared plus 4x minus 3. So what is there? We just get 10 into 2x minus 3 squared again into 12x squared plus 4x minus 3, which is the 2y dx squared. That's how we do that. Whenever they ask you for the second derivative, I'm expecting you to handle it in that way. Then let's move to another example. We are now going to look at the second derivatives for parametric equations. For parametric equations, that's what we want to look at with the second derivative. That's what we are going to look at for the second derivative. So, for parametric equations, for parametric functions, the 2y dx squared is the same as d dt of dy dx times dt dx. This is the formula which is given, such that dt can cross with dt, you remain with d times this, you get the 2y dx squared. That's where it came from. So let's look at example. Example 1. Given that x equals t squared plus 1, comma, y equals t cubed plus 2t. Change of saying, find dy dx and the 2y dx squared in terms of t. So let's pay attention here with this. We are given x equals t squared plus 1. First get the x dt. When you're getting the x dt, you're getting the 2t. And equally we have got y equals t cubed plus 2t. And we get the y dt. What are we getting? 3t squared plus 2. Then we shall say using dy dx equals dy dt times dt dx. What is dy dt? Our dy dt is 3t squared plus 2 times. What is dt dx? 1 over 2t. So, can we move on? What is dy dx? Dy dx becomes 3t squared plus 2. 3t squared plus 2 all over 2t. That is our dy dx. Now, this is what we call dy dx in terms of that. Now, I want to get the 2y dx squared. I will say that the 2y dx squared, here we are going to say d dt of dy dx times dt dx. That's what you should know in your mind. So, that means we first get d dt of dy dx, which is the same as d dt. What is the dy dx? Is 3t squared plus 2 out of 2t. So this is our quotient. This is u, v. So how do we use that one? From v du dt minus u dv dt all over v squared. What is our v? Our v is 2t times, what is the u dt? When you translate that one, we get 6t minus, what is our u? 3t squared plus 2 times 2 all over, what is our v? 2t all of it squared. What is it now? Total of t squared, in open the brackets, minus 6t squared minus 4 all over 4t squared. So what do we do? This minus this, we're getting 6t squared minus 4 all over 4t squared. So, after coming out with that, we can easily factorize out. That is our d, this is d dt of dy dx. Now, our interest is to get the 2y dx squared. As we have already said, our interest is to get the 2y dx squared. So, what is our d dt of dy dx? We have already got 6t squared minus 4 all over 4t squared times, what is dt dx? We just take the reciprocal. It becomes 1 over 2t. So, what is common up is a 2 into 3t squared minus 2 out of 8t cubed. So 2 reduces, what do we get? What do we get? So here what we get is, we are getting 3t squared minus 2 all over 40 cubed, which is d2y dt squared in terms of that. So that's how we can deal with the second derivative when given the parametric equations. So we are going to try to copy this one down and practice them more. So when they give you terms of parametric equations, you do like that. So we are going to look at also another one in terms of implicit function. If I go implicit function, we're going also to give you another one in terms of parametric equations. That's what we're going to look at. We're going to look at another one related to that. As an example, given that x equals t squared plus 1, y equals 2t cubed plus 5. Find the 2y x squared solution. So we are supposed to say x equals t squared plus 1. We look at the x dt. What are you getting? 2t. We'll also go to y, 2t cubed plus 5. We look at the y dt. What is the y dt? 6t squared. Then from there we shall say using the y dx equals the y dt times dt dx. What is the y dt? The y dt is 6t squared times, what is dt dx? You take the reciprocal, 1 over 2t. What are we getting? We are getting 3t, which is the y dx. Now, when they say get now dt of the y dx, which is the same as dt of 3t. What are you getting? You're getting 3. Then, from there we say using the 2y dx squared equals dt of the y dx times dt dx. So what is dt of the y dx? Is already 3 times, what was your dt dx? dt dx was a reciprocal, which was 1 over 2t. 1 over 2t, which becomes 3 over 2t, which is 2y dx squared. That's how we handle such a kind of the numbers. So we are going to do the last item on those second derivatives which involve implicit function. Then we have marked our staffs of the differentiation of the implicit and parametric equations. So next time when we meet, we submit at other staffs. So we are going to do the last item, that's the last example. Then we end up on that. So the last example goes, if x squared plus y squared plus 5xy plus 6x equals 4, find the 2y dx squared. So what I'm going to do is this, we are going to apply the same idea. So we look at the solution. We are going to look at d dx of x squared plus y squared plus 5xy plus 6x equals d dx of 4. So can we differentiate by x squared? What do we get? We get 2x plus 2y, the y dx plus 5. apply our product. What is our v? Y times that plus x times dy dx, very good, plus 6 equals 0. We open the brackets, we get 2x plus 2y dy dx plus 5y plus 5x dy dx plus 6 equals 0. So, can we correct those ones with dy dx? What are we going to have? We are going to have 2y plus 5x, very good, dy dx plus 2x plus 5y plus a 6, else equals 0. Take that on the other side. So we are having 2y plus 5x dy dx equals negative 2x plus 5y plus 6. We divide by this, we remain with dy dx. What is it? Negative 2x plus 5y plus 6 all over 2y plus 5x. So that's how we get our dy dx. Then to get the 2y, dx squared, we are going to look at ddx of dy dx. So we're going to differentiate this one afresh. So when we continue differentiating that one, then what will come out will be the second. So we're going to say the 2y dx squared is the same as ddx of what was dy dx is already up, which is already negative into 2x plus 5y plus 6 all over 2y plus 5x. So then from there we apply the quotient rule, which will go v du dx minus u v dx all over v squared. What is our v? 2y plus 5x. When you differentiate up, you remain with the negative into 2 plus 5 dy dx. Okay, minus what is our u? Comes now plus 2x plus 5y plus 6. Differentiate down, you get 2 dy dx plus 5 all over 2y plus 5x the whole of h squared. So I want you as learners who have been attentive in class to proceed with that, and you come out with a clear answer. So with those few words, allow me stop from here, and I say continue practicing. The more you practice,